Hi, my name is Will Kennedy. I'll be talking to you about Trollup, which is what I call a hybrid ZK optimistic network extension with flexible verification for Solana, which is another way of saying I didn't know what the best approach to take was, and I ended up with this. But essentially, Trollup is a ZK rollup, but it's unique in the fact that it allows optimistic and non-optimistic transactions to take place. And my thought there was to kind of utilize the strengths of the different types of rollups and mitigate their individual weaknesses, and provide some flexibility for users. And the goal is the Trollup libraries are modular, so you can build off of them, or potentially the hope is to turn this into a rollup as a service for Solana. So the Trollup is using the Solana SVM to run programs off chain. It can load programs locally or pull them from the main chain, and it can do proof verification and signature verification both on chain and off chain. And it's two main components: the Trollup API, which is basically an execution engine, the settlement layer, a basic DA layer, and then a separate Trollup validator that handles off-chain proof verification. Let's go into a quick demo. So here I have the Trollup validator running and a Trollup API running, both locally, and there are two programs out on DevNet, one for validator signature verification and one for proof verification in the case of optimistic transactions. So let's go ahead and run this send transaction, which basically sends a non-optimistic transaction to the Trollup API. All right, so what we see here is that the API picked it up, loaded the accounts, and executed the program, and then sent it the proof package to the validator. And we hop over to the validator. The transaction succeeded because the proof was valid, and it sent a response saying, okay, yeah, that's cool, here's the signature, and come back and see that, okay, successful response from the validator, and let's finalize everything and create a new block. Let's go to run another example. This one's for an optimistic transaction. In this case, the validator will be bypassed because it's simulating sending the transaction and then getting the proof from the Trollup API and putting in your own public inputs, and then sending that directly to the on-chain proof verification. And then it picked that up, so it's listening for state root changes from the proof verification program, and then it goes and updates the state and creates a new block. And we can go verify those changes here. Yeah, so this is the non-optimistic. Anyway, thank you for taking a look at it. Please reach out to me if you want any more information. Thanks.